Welcome back to Learning with me, Ms. Killen here at MPB. We are at the end of Unit 1. We're on Lesson 7. So let's see what we've got. We've got polynomial expressions. I can classify polynomials by term numbers and degrees while also identifying lead terms and coefficients. I'm looking at APR 1. So let's go ahead and dive on in to see what we're looking at. So some vocabulary that we need to make note of. Now, on a sheet of paper or maybe on the vocabulary page, we want to make sure that we are keeping up with these different terms. We've got term, which we're going to look at and see what that means and what that entails. Polynomial expressions, polynomial, coefficient, degree, constant, binomial, trinomial, monomial, and a variable, which we've talked about variables already, but we're going to look at it in a different light. So, we define a term many ways. It can be a constant, which is just a number. This would be my constant. It could be just a variable, or it can be a mixture or a combination of them. So this is a term, this is a term, and this is a term. So there's multiple ways that I can show a term. And depending on what type that we're looking at, I could have multiple variables in there, or maybe I could have exponents. So there's multiple ways that we can see these terms. So let's look. It says, look at this expression, 4x squared plus 3y minus 7z plus 12. This is called a polynomial term, or excuse me, a polynomial expression. Now it asks us how many terms do we notice? Well, let's see. I'm going to use the swoosh method. Now, I've been saying this ever since I've learned it. What I do is I put some type of indicator under my different terms. So I can say this one and this one are the same, or this one and this one is different. So I'm going to swoosh this expression to show how many terms we have. So here we go. I have one term, I have two terms, I have three terms, and I have four terms. So I have four terms in this expression. Now, if we write them down, let me show you what I don't want you to forget when you write different terms down. So I have 4x squared, a positive 3y, a negative 7z, and a positive 12. Now, Ms. Killen, why did you put their operation symbols with them? Those operation symbols tell us if they're positive or negative, or what I'm going to do when I have to maybe put multiple terms together, or like terms. So you always want to make sure that you're looking at these plus and minus signs, which are going to be positive or negative. Good job. So let's see. It says polynomial expressions can be anything from one term to many terms. The chart gives examples of three different types of polynomials. Now, if I have one term, there is a specific name for one term. It's called a monomial. So let me show you what that looks like. It's M-O-N-O-M-I-A-L, monomial. Let me make sure I spoke that right. Yes. Now, when I have an example of a monomial, it's just one term. So I'm going to give you multiple examples. You write the one that you think that will best help you. So we could have maybe x or 3x, or we may have 4x squared. So that's three different examples of a monomial. So the next one, we have two terms. Now, what do I know that's got two of something? What about a bicycle? How many wheels does a bicycle have? It has two. Bi means two. So if I had an expression that had two terms, it would be called a binomial. So I've got B-I-N-O-M-I-L, binomial. And let me give you some examples of that binomial. It could look like y plus 3. It could be 3t minus 7, or it could be 5x squared plus 6y. All three of those are examples of binomials. Now my next one says 3. What do we know about something that has 3? What about a tripod or a tricycle? Everybody when they're little has a tricycle. So a tricycle and a tripod, what do we know? They have three wheels or 3 legs. So then if I have 3 and I have to use tri, what do you think the word is? Trinomial, exactly right. So let's write that. Trinomial. And so let me give an example of it. I've got 3x squared plus 6x minus 11, or x plus y plus z. Both of those are examples of trinomials. Now, Ms. Killen, what about 4 or more? Would we have more? Yes. Sometimes we'll have 5 terms, or sometimes maybe have 7 terms. And we can't keep finding a word for each of them. So what we've done is we have a collective name. So when we have 4 or more terms, they are considered polynomials. Now, we also considered 1, 2, and 3 polynomials, but since they have a specific name, that's why we usually say 4 or more are polynomials. So let's get an example of that polynomial. So I've got 2t minus 3p squared minus 4m plus 12. Okay, that's 4 terms, 3 different variables. So that is a wonderful example of a polynomial. So let's look some more. It says polynomial expressions, and here is what we had earlier. It says, for number 1, degree of a monomial or a monomial is the sum of the exponents of the variables. So let's look right here. So here's my monomial. The sum will only have 1, so we would say this has the second degree. That's how many degree that monomial is. Let's look at the next one. 6y minus 7. I don't see a exponent, so it's an understood 1. So this would just be to the first degree. All right, trinomial. 3x squared plus 2x minus 1. That would be the what? The second degree. So now look at this bottom one. I have multiple variables, but I'm looking for the highest to find the degree when I have multiple variables and multiple exponents. Even though we don't see them, the ones are still there. So what's the highest exponent? It's a 2. So that would be the second degree. And that leads us into number 2, degree of polynomial, the degree of the term with the highest degree or the highest exponent. So we looked at that. So let's look at some more examples. What about if I had this? 4y to the second, z to the third. That's one term. So over here it says the sum of the exponents. So that means what I'm going to do is I'm going to add these exponents. So it would be the 5th degree. Let's do one more example like that. So let's see. What about that one? So I see that this middle term has 2 exponents. I'm going to add them. So I would say this is to the 8th degree. Good job. All right, so let's see what else we've got. It says to write a polynomial in standard form, we do these 4 things. So you might want to make sure that you write these on your notes page. We're going to write terms in descending order by degree. Descending order we know is from highest to lowest. We're going to have leading term in polynomial is the one with the highest degree. So there's another vocabulary word, which is leading term. It's the one with the highest degree. My leading coefficient is the coefficient in the leading term. And we know coefficients as the number in front of a variable. And then variables will be in alphabetical order. So these 3 are key to know when we're wanting to write these polynomials in standard form. So let's look. Let's put this into practice. When you put polynomials or polys in standard form, put highest exponents and go from highest to lowest. If a variable is in the denominator, it is not a polynomial. Polys are defined as expressions with terms that have variables in the numerators raised to non-negative integer powers. So there's yet another noteworthy sentence. We need to make sure that we're writing these notes either on our notes pages or in our notebooks so we can go back and refer to them when we're doing our independent practice or when we're doing this time to mastery. So here we go. Let's do some practice. It says first, circle the following expressions that are polynomials. So we're going to circle the polynomials. Then we're going to name the type of polynomials. Then I'm going to give its degree. Then I'm going to talk about the leading coefficient. So I have annotated my question, knowing I'm going to do multiple things. So what I'm going to do is I'm going to do each of them. I'm going to find what type of polynomial, or if it's a polynomial. Then I'm going to go back and do the type of all of them. Then I'm going to go back and give the degree of all of them. Then I'm going to go back and find the leading coefficient. So let's see what we've got. Let me get a different color. So let's use blue. So when I look at number 1, what type, or is it a polynomial? I see that I have numbers and variables, and I have exponents. Exponents are whole positive numbers. So this would be a polynomial. So when I look at number 2, I notice I have a variable in my denominator. Well, that is the example of the definition that it's not a polynomial. So number 2 is not a polynomial. I look at number 3. I have a fraction, but it is a coefficient. Then I have variables, and I have whole positive integers as my exponents. So this would be a polynomial. Number 4, I'm looking at, I have whole numbers. I don't have any fractions. All of my exponents are positive integers, so this would be a polynomial. Now looking at 5, I see whole numbers, I see variables, but what do I notice about my exponents? I have one that is negative, so 5 cannot be a polynomial. So now let's go to the next thing it asked me for. What type is it? Number 1. What does number 1 look like? It is a monomial or a monomial. Number 3, I see 1, 2, 3, or if you swoosh it. So what did we say 3 terms were? That's a trinomial. And number 4, let's see, 1, 2, 3. So that one would also be a trinomial. Now I'm going to look at the different degrees that they are. Now when I have a monomial, I have to add those exponents. So when I add 3 and 4, what do I get? I get to the 7th degree. When I am looking at number 3, I want to see the highest exponent, which would tell me my degree. So here I have my 7th degree. And number 4, when I look at my highest degree, I see a 7, but this one right here has 2 exponents. So when I add them together, what do I get? I get to my 8th degree. Now, last thing it asks for, we're going to do it in purple. It asked me for the leading coefficient. The leading coefficient is in the leading term. So let's look at number 1. Obviously, my leading coefficient would be the number 9. Now, what about the number 3? Yes, it's going to be the number 7 because we said this was the leading term. And then what about number 4? Well, we said this was the leading term, so obviously it's going to be 11. That gives us everything in a true example of all those different points that we have to follow to write these polynomials. All right, so let's see. When you have a negative in the exponent, you must make it positive by turning the number or variable into a fraction. And we saw how we did that. when we have x to the -1, my x goes on bottom and my 1 goes on top. So then that shows me when I have a variable in my denominator, it cannot be a polynomial. All right, so let's go. When we do operations with polynomials, we must always remember PEMDAS. Now, in elementary school, you may have learned, please excuse my dear Aunt Sally, or you may have learned PEMDAS. Both of them are absolutely correct. We just need to make sure we know how to work it. So let's look at this. Obviously, I have parentheses and exponents. We know that. But when we have this multiplication and division, it's from left to right. When I look at this addition and subtraction, it's also going to be from left to right. So let's look at this first box. It says to make equivalent expressions, try to do all distributing, then combined like terms. Now, Miss Killen, what do you mean do all distributing? When I have something that I am distributing, which you've learned, but we're going to refresh. When I distribute something out, I give the same amount to this person, I give the same amount to this person, I give the same amount to this person. So when I'm distributing in an expression, I'm multiplying to all the terms by the one on the outside of the parentheses. Now, Ms. Killen is old and she forgets. So what I do is I draw my arrows. That's how I can remember what I'm multiplying to. So let me show you what I'm doing. I'm going to distribute this 3 to this 14, to this 6y, and to this -y squared. So then here I am with my multiplication. 3 times 14 is 42. 3 times a positive 6y is plus 18y. And 3 times a -y squared would be -3y squared. Now, I don't have anything to multiply but an understood 1 right here, so I can just write them as they are. Now, true, this is an equivalent expression, but I always like to get my like terms together. So let's look and see what that means, putting like terms together. So here we go. So let me get a different color. We'll do red. I have only one term that has a y squared. So I'm going to put -3y squared. Nope, I don't. I have 2. Look at that. So Ms. Killen, I do what? All right, so since I have 2 that has a y squared, I have -3 plus 1 would give me a -2y squared. Good catch. I only have one term that has just a y, so I'm going to bring it down. But I have 2 constants. So 42 plus 4 is going to give me a 46. This is my equivalent expression to my original problem. I have distributed, and then I put all of my like terms together. So let's try this middle one. It says always write your polynomials in standard form, which we did, but now let's look at this one a little bit closer. I'm going to get a different color for this one. We'll get blue. So here we go. I'm going to distribute. Miss Killen uses arrows, and that's okay. And I'm going to distribute 2 times. So here we go. -6x times 3x. Well, -6 and 3 is -18. And then when I multiply my bases, which are x, I add my exponents, which would be a x squared. And then -6x times 8 is going to give me a -48x. +4 times a +6 gives me a +24. And then +4 times a +x gives me a +4x. I'm going to put like terms together. So let's see what that looks like. I only have one term this time that has an x squared, so I'm going to go ahead and write that down. I have this one and this one that has just an x. So -48 plus 4 gives me a -44x. And then I'm left with my constant. A constant does not have a variable. So I've taken from my original, I've put like terms together after I distributed, and then I come back with a equivalent expression in standard form. So it says when your coefficients add your exponents, when you are multiplying your coefficients, you add your exponents. When you divide your coefficients, you're going to subtract your exponents. So we want to make sure that we have these. Make sure that you have this in your notes page. When you are multiplying those coefficients, what you're doing to your exponents. When you're dividing those coefficients, what you're doing to those exponents. Let's do some more practice. We are multiplying 4a squared b to the 5th to everything in the parentheses. So we're going to multiply here and multiply here. So 4 times 2 is 8, and then when we multiply our coefficients, we are adding our exponents. So 2 plus 4 is going to be 6. Then b to the 5th and b, I am adding my exponents. So it's going to be b to the 6. And then I'm going to multiply this 4 to the 5 and get a positive 20. A squared and a, I would get a to the 3rd. B to the 5th and b, I would get b to the 6th. And then we have this one that is to the 3rd. Now remember when we had a power to a power, we are multiplying those exponents. So I am raising everything to the 3rd. So I am going to have 10 to the 3rd would be 1,000. A to the 3rd again would be a to the 9th. B to the 3rd again would be b to the 9th. So if I put all of these together, it is going to look like this. And let me make sure that I have that b to the 6th. Good job. All right, so let's do number 2. So I have got 7y to the 5th minus 3y to the 3rd plus 8 minus 12 plus y to the 3rd minus 6y to the 5th. So what I'm going to have to do is I can put together like terms. So I'm going to rewrite this. So I'm going to have 7y to the 5th minus 3y to the 3rd plus 8. I'm going to subtract, and now for this second term, I'm going to put like terms underneath. So I have my constant, which is a positive 12. I have my y to the 3rd, which is positive with an understood 1. And then I have a negative 6y to the 5th. Now I can just simply subtract. 7 minus a negative 6, when I subtract a negative, that's just like adding. So I'm going to have 13y to the 5th. Negative 3 minus 1 is going to give me a negative 4y to the 3rd. And then 8 minus 12 is going to give me negative 4. All right, so let's do this last one. Let me get one more color. Let's do green. So first thing I need to do is get my parentheses out of the way. So I'm going to distribute here. So I'm going to have 4 times 3 is 12. X times x gives me that x squared. 4x times a negative 7 gives me that negative 28x. And then I'm going to bring this down and see if I can put any like terms together. So this is a like term and this is a like term. So I have 5 plus 12 gives me 17x squared. This is a term that I can put together, and this is a term that I can put together. 6 plus a negative 28 is going to give me negative 22x. And then I have my constant, which is by itself. All right, it says time for you to master. Now, there's going to be 4 questions on 2 different slides. I'm going to show you the first slide and read it to you, then we're going to pause. Then when we come back and work that first slide, we'll go to the next slide. I'll read it, we'll pause and work it. So here we go. Name the type, degree, along with the leading coefficient in the following. And there's our expression. Number 2 says write the following in standard form. And there's our problem. So y'all go ahead and work these, pause the video, work independently or with your table partner, and then come back and let's see what we got. All right, so now that you've got the work done, let's check my work, watch what I do, and make sure I get it right. Here we go. So the first thing I'm going to do is tell what type I have. Well, I have one term, I have two terms, and I have three terms. So I'm going to say I have a trinomial. Oh, Miss Killen, but is it a trinomial? Well, let's see. It's not. I have one term here and one term here. So that means we really have to make sure of those positive or those adding or those subtractions in these different terms. So we always make sure that we look for those adding and subtracting signs. So instead of a trinomial, we would call this a what? Yes, a polynomial. Good job. So we've got a polynomial. Now, it also asks me for the degree. So what is my highest degree that I see? Yes, so I've got to the third degree. All right, so what is my leading coefficient? Well, this would be my leading term. So my leading coefficient would be a 6. That would be my leading coefficient. Good job. Number 2, it says write the following in standard form. Well, before I can write the following in standard form, I've got to put all my like terms together. So let's watch and see how we do that. I have a negative 36x squared, and I have another x squared. I have just an x, and I have just an x. Then I have a constant, and a constant. So I'm going to put like terms together. Negative 36 minus 7 is a negative 43x squared. Positive 9 plus 12 is going to give me plus 21x. Then I have 91 minus 3 plus 35, which is going to give me a positive 123. Check your work, check my work, make sure that we've got all of our like terms together and that we put all of our minus or plus in the right place. We always want to make sure that we've got those positive and negatives correctly. All right, so let's look at our next one. All right, it says write an equivalent expression for each of the following. So go ahead and pause the video. Either you and your table partner work together. Y'all work these two problems and then come back to me and we'll see what we got. All right, so I'm going to work these. You check my work, make sure we're putting all of like terms together, and then we'll see what we got. So here we go. So in this first part of number 3, I noticed that I can put this and this together, and I can put this and this together. So I have negative 4x plus 2. Here I'm going to have to distribute, so I'm going to have plus 84 plus 35x plus, nope, positive plus a negative is a negative. So I'm going to have a subtraction of 7x squared. I want to go ahead and put like terms together. So here we go. I only see one with an x squared. This one and this one have an x, a constant, and a constant. So I have negative x squared plus negative 4x plus 35x is going to be plus 31x. 2 plus 84 is going to give me a plus 86. So here is my equivalent expression. All right, so let's look at number 4. Watch me as I work. Make sure I am distributing correctly. So here we go. I'm going to distribute here. I'm going to distribute here. So I'm going to put negative 4y times 3y is going to give me a negative 12y squared. Negative 4y times a positive 6 gives me negative 24. Got to make sure we get those positive and negatives correctly. So it's going to be a negative 24y. Then I have 10 times 3y to the cube. So I have plus 30y cubed. 10 times negative 4y is going to give me minus 40y. And then 10 times a positive 2 is going to give me plus 20. I'm going to put like terms together. So just a y, just a y, just a y. I have just squared. I have cubed. And then I have my constant. So let's write this in standard form from least to greatest. So here we go. So I've got 30y cubed. Then I'm going to put my squares together, which are minus 12y squared. Then I'm going to put just my y's. 9y minus 24y minus 40y is going to give me minus 55y. Then I have my constant of plus 20. So I have taken this whole problem and written my equivalent expression, putting terms together, doing that distributive property, making sure that I'm putting like terms together. That's the key. You will hear me say that multiple times the more into this math that we get, putting those like terms together. All right, so let's not forget what the types of polynomials are. We have the binomials, the trinomials, the monomial, and the polys. How do I tell the degree? Remember, we have to look at that highest exponent, or if there's more than one exponent, we have to add those together in the highest number. And then what is standard form? We said that our exponents are going in descending order, meaning from the highest to the lowest. I am so glad that you've been here throughout this whole unit of numbers and expressions. We are at the end. I think we've done an awesome job. Keep doing the practicing, keep doing that extra independent work, and I promise you it's going to get a whole lot easier. I hope that you've had fun, and I hope you have a great day.